Multiplying rational expressions. So this is going to be in the form where we have an a over b times c over d, and we're going to be looking at how to work with this. We do know that when we're multiplying fractions, we know that we multiply straight across, and we can combine them into one fraction, a times c over b times d. We're going to be utilizing that idea from our more basic fraction knowledge to work with polynomials where substitute polynomials in for a, b, c, and d, and then see how we can simplify it out. So we're going to compare operations on rational expressions to the same operations on rational numbers. We're going to find the non-permissible values where b and d would be, and determine the product, and in our next lesson we'll be learning about the quotient, how to deal with a over b divided by c over d, and then put it into simplest form. The basic steps of this: you're going to factor all of your polynomials. If a, b, c, or d is in a binomial or trinomial form, factor it as much as you can, and then state the non-permissible values, and then cancel out any of your common factors. So starting more simply here, before we get into the polynomials, we'll just work with some monomials here. When you're multiplying two fractions, again in the form a over b times c over d, you just multiply straight across. So this would become 5 times 4xy over 8x times 15y. And then you combine together your coefficients if there are. So 5 times 4 is 20, and so that would be 20xy. And then 8 times 15 would be 120. And then x times y is xy. And then simplify out what you can. The common factors in the top, we can simplify 20 and 120. We can divide them both by 10, and then 2 over 12 we can divide by 2, and you get 1 over 6. X divided by x cancels, y divided by y cancels, so 5 over 8x times 4xy over 15y simplifies to 1/6. Now let's do another one. If we had 4x over 3xy times x over 8x, multiply straight across, and you would get 4x times x over 3xy times 8x. Combine together any coefficients and any variables. So in the top we just have 4, x times x is x squared, over 3 times 8 is 24, x times x is x squared, and then y is by itself. Simplify what you can. X squared divided by x squared is gone. 4 divided by 24, they can both be divided by 4, so you're left with 1 and 6, and then y is left over. So what we have as our final answer there is 1 over 6y. So if we had it in polynomials form, each of these trinomials you'll need to convert. You'll need to factor and turn them into two binomials before you multiply straight across. You could multiply straight across in the trinomial form, but it'd be a heck of a lot cleaner, and it'll be a lot easier to see the factors if we factor them first. So a little bit of work here. We need to find each of these. All of them can be factored. So we're looking for two numbers that multiply together to give you -7, but add together to be -6. So if we looked at our factors of -7, that one's a prime number. So just 1 times 7 is our only option. The only way to get a -6 is to do -7 plus 1. So let's split that first one into x plus 1 times x minus 7. And then x squared, or sorry, we're looking for two numbers that multiply together to give you 4, and add together to give 5. So look at all your factors of 4. 4 can be done with 1 times 4, or with 2 times 2. The only way to get plus 5 is with the 1 and the 4. So x plus 1, x plus 4. Now we're multiplying, so we are going to multiply straight across and combine all of these. So we're going to make one big fraction, but we got to do these trinomials as well. So we'll need to decompose these. We'll need to decompose that center term in order to, because these have a coefficient in front of the x squared, they have an a term. So you multiply the a and the c, and that is 8. So we're looking for 2 factors of 8 that can give us 9. So 8 can be done with 1 times 8 or with 2 times 4. The only way to get plus 9 is with the 1 and the 8. So we need to decompose that term. So we'll have 2x squared plus 1x plus 8x plus 4. You group the first 2 terms and the second 2 terms and add them. From the 2x squared plus x, the biggest thing you can factor out is an x, and you'd be left with 2x plus 1. The biggest thing you can factor out from 8x plus 4 is 4, so plus 4, and you'd be left with 2x plus 1. Again, if you've done it right, your brackets should be the same. And now from these 2 terms, the x times 2x plus 1 and the 4 times 2x plus 1, we're going to factor out the 2x plus 1 out of this and this. And what you're left with is x plus 4. So that's what this trinomial is going to turn into. So 2x plus 1 and x plus 4. Something you should look for, I should mention, before you start going into the decomposition, check and make sure there's no common factor that you can pull out from the start, because that might make it a lot easier. 3 and 23 are both prime numbers, so they're not going to share anything. So this one we're going to have to decompose. There's nothing to pull out at the start. So let's do that. So you multiply the a and the c, so 3 times 14 is 42. And we're looking for all of the possible ways we can get 42. So 1 times 42, 2 times 21, 3 times 14, and 6 times 7. Oops, 6 times 7. So we need to get negative 23 from a positive value. So both of the numbers are going to need to be negative in order to end up with that positive value. So if we combine together 2 negatives, then the 2 and the 21 are the only way to get 23, if negative 23 if they're both negative. So that's what we decompose that middle term into, the negative 2 and negative 21. So 3x squared minus, doesn't matter which one you do, minus 21x minus 2x plus 14. And then you're going to group the first 2, group the second 2, add them. Now, from 3x squared and 21x, they both share a factor of 3 and an x. So we're left with x minus 7. Now from the negative 2x and the 14, you're going to factor out that negative 2. That is going to change this to be a negative. So 2 and 14 both share a factor of 2, and you want to pull out that negative. So this will become negative 2 times x oops, minus 7. Again, if done right, your brackets should be the same. From these two terms, the 3x times x minus 7 and the 2 times x minus 7, we're going to factor out the x minus 7. And when we do that, what we're left with is 3x minus 2. So that's what we are going to put in place of our polynomial up here. So x minus 7 and 3x minus 2. So we've got all of our terms now. We do need to identify our non-permissible values at this point. In this form, it's hard to see what the non-permissible values are. In this form, it's a lot easier. Oops, this was supposed to be a 1. Missed that. We need to do, there's going to be 4 non-permissible values. So we'll need to work all those out. So our non-permissible values, let's first do the x plus 1. Again, you want to find out what would make that equal to 0. Because, again, if this was 0 times whatever times whatever times whatever, the whole denominator is equal to 0. So that'll make your number a non-real number. So we want to find out what would make that 0, and that's going to be one of our values that we can't use. So x plus 1, you solve for x by subtracting 1 from both sides, and you'll have x is equal to negative 1. So negative 1 doesn't work. Do the same with x plus 4 is equal to 0. Solve for x by subtracting 4 from both sides, and negative 4 doesn't work. That would make this term equal to 0. Do the next one, x minus 7 equals 0. Add 7 to both sides to solve for x. 7 doesn't work. And then the last one, 3x minus 2 is equal to 0. Two-step algebra problem, you're going to first add 2 to both sides, and you'll have 3x minus 2, oh, whoopsie, let's go into the other side. You're going to add 2 to both sides, and you'll have 3x equals 2, and then divide both sides by 3, and x cannot equal 2/3. So our non-permissible value list at this point, non-permissible values is in order from greatest or from least to greatest, -1 or -4, -1, 2/3, and 7. So there's all of our NPVs for this equation. Now we solve, we simplify. Look for any terms in the top and the bottom that are shared. Anything divided by itself is 1. Doesn't matter what it is. So x plus 1 divided by x plus 1, those will cancel out. X minus 7 divided by x minus 7, those will cancel out. And x plus 4 divided by x plus 4, those are going to cancel. And what you're left with is 2x plus 1 divided by 3x minus 2. And there's nothing shared between them, so that's as simplified as you can get. So 2x plus 1 over 3x minus 2. And there is our simplified form for this product with these non-permissible values. Let's do another one. So this one is a trinomial that we're going to have to work with. So 4x squared plus 8x plus 4. So multiply the a and the c, and you get 16. We're looking for two factors of 16 that can add together to be 8. So 1 times 16, 2 times 8. Oops, don't know why I did that. 2 times 8, and 4 times 4. The only combination that will give us plus 8 is a positive 4 and a positive 4. So we have to decompose that middle term into that. Didn't take my own advice. You could continue with that, but let's, yeah, if you started down this path, let me point out the fact that all three of these terms share a common value. So we are going to put a pause on that, and let's factor out a 4 out of 4, 8, and 4. So we're going to turn that into 4 times x squared plus 2x plus 1. That's a lot easier of a polynomial to deal with. We're looking for two factors that multiply together to give us 1. The only way we can get 1 is 1 times 1. And if you add these two together, you'll get 2x. So we're going to break this term into x plus 1 times x plus 1. Don't forget that you factored out that 4 first. And then this next term here, this 3x minus 3x squared, you can factor out a 3x from these two terms, and you would have, so 3x, so times 3x, and you'd be left with 1 minus x. And in the bottom there, we're going to have 7x, and then x squared minus 1. This is a tricky one to look at because you don't have that middle term, but you got to remember the difference of squares. Look out for it. It's going to be the thing that probably trips you up the most. So if you have an x squared minus a perfect square, this will decompose into, this will factor into the square root of this plus minus the square root of this. So that breaks into the square root of x squared is x, and then plus minus the square root of this, which is the square root of 1 is 1, so x plus 1 times x minus 1. So we've combined them together. Let's find our non-permissible values from these three terms down here. So we'll do our NPV list, and 7x can't equal 0. Oops, 7x can't equal 0. So divide both sides by 7 to solve for x, and 0 divided by 7 is 0. So if 0 is here, 7 times 0 would make that part not work. Then x plus 1 equals 0. Subtract 1 from both sides, and you'll have x is equal to negative 1. So negative 1 would make this 0. And our last one, x minus 1, add 1 to both sides, and you'll find that if x was 1, that would make this term equal to 0. Okay, so a couple things to do here. One, if you have any of these coefficients sticking out like this, multiply them together. These ones on the outside you can combine. So 4 times 3x, that's going to equal 12x. And then look for things in the top and the bottom that you can cancel. We've got an x plus 1 and an x plus 1, so let's get rid of those. And then we've still got this 1 minus x. And in the bottom, we still have a 7x and an x minus 1. Now these two look real similar, and I've got a little tip down here for you in how to work with this. They look really similar, but they're not the same. This is a negative x, and this is a positive x. This is a positive 1, this is a negative 1. Notice how they have the opposite signs of each other. So there's a neat little trick you can use to change either one of these into the other. And that if the only difference between them is their signs, then multiply this one. It doesn't matter which one you choose, but I'm going to move towards having a positive variable. It's a good habit to have. So let's change this one by factoring out a negative 1 out of it. So we'll have 12x times negative 1. We're going to factor out a negative 1, and when we do that, this changes to a positive x and a negative 1. In the bottom, we still have 7x. We haven't changed anything there, and then x minus 1. So there we go. Now we have something in the top and the bottom that we can cancel out. We just had to pull out this -1 term from it. So the x minus 1's go. 12x times -1 will be -12x. And in the bottom we have 7x. At this point, x divided by x can cancel. But 7 is a prime number, so unless 12 is a multiple of that prime number, you're stuck there. So nothing we can do there. If this was a 14, we could simplify, but nowhere to go, so our final answer is -12 over 7, and our non-permissible value list from least to greatest is -1, 0, and 1. So a couple for you to try. I'm going to note this pi before you get into it. Remember, anything divided by itself is gone. So I know this pi might look scary, but anything divided by itself, it cancels out. So pause it, give it a go. Don't forget this as well. You're going to have one of those positive numbers minus a variable. Don't forget this factoring tip in how to change that around. That may be helpful. Pause it, give it a go. And I'll do it now. So 2 minus d, that's the same thing as this 3 minus y. Notice how it's very similar to this d minus 2. We're going to want to flip that. We're going to flip that by factoring out a -1. I'm going to do that right out of the gate. So -1 times, to factor a -1 out of the 2 minus d, and it becomes a positive d, not plus, minus 2. And then that's times 2 pi r h. In the bottom, we're going to have 2 times pi times r times d minus 2. Okay, let's do our non-permissible values. We've got 2 variables here. Pi isn't a variable. Pi is a value. So r and d, we need two values that wouldn't be acceptable for r and d. So r, our r values, non-permissible value list. So we want to find out what would make this term equal to 0. So 2 pi r equals 0. Solve for r by dividing both sides by 2 pi. And 0 divided by anything is just 0. So r is equal to 0. If you put in a 0 here, you'd have 2 times 3.14159, etc. 2 times pi times 0 would make this unit 0, and that's no good. We also need to find out what would make d 0. So d minus 2 is equal to 0. Solve for d by adding 2 to both sides, and you'll have d equals 2. So positive 2 doesn't work for d, and 0 doesn't work for r. Okay, at this point we want to simplify whatever we can. We've got a 2 in the top, a 2 in the bottom. We've got a pi in the bottom, pi in the top, r in the bottom, r in the top, and a d minus 2 in the bottom, and a d minus 2 in the top. So what we're left with is -1 times h. And since all of these things canceled, this is a worthy note. Remember that when we say cancel, what we really mean is we're reducing it to 1. 2 divided by 2 is 1 over 1. Pi divided by pi is 1 over 1. So if all of these things are canceled, it doesn't become a 0. It's 1 times 1 times 1 times 1, which is just simply 1. So in the top, we're going to have -h over 1, or even more simply, just negative h. Our non-permissible values is r cannot equal 0 and d cannot equal 2. Next one, so we have this perfect square minus a perfect square. This is going to be a difference of squares that you got to deal with. So square root this plus minus the square root of this. So that will turn into y plus 3 times y minus 3. And for the next one, r squared minus r, you're going to factor out an r first. And this becomes r minus 1. In the bottom, r cubed minus r, let's factor out an r. They both share an r. And we're left with r squared minus 1, difference of squares. And then over here, we want to flip this around. We don't like having negative variables, so let's pull out times, we're going to pull out a negative 1 and turn it into y minus 3. This is almost factored. We need to deal with this difference of squares still, so we're going to have to write this out one more time. But we can do a little bit of work here. We can start canceling some things to make it easy. Actually, before we do that, no, we're going to write out the whole thing because we need our non-permissible value list. So y minus 3 times r minus 1 over r. So square root of this plus minus the square root of this to get your difference of squares. So this turns into r, square root of 1 is 1, so minus 1, and r plus 1. And then we're timesing by negative 1 and y minus 3. Okay, let's do our non-permissible values. So NPVs. What would make r equal to 0? That one's nice and easy. Just 0 would make r equal 0. And then if we had r minus 1, then what would make that equal to 0? Add 1 to both sides, and you'll find that if 1 was there, that would be no good. And then r plus 1, want to find out what would make that 0 by subtracting 1 from both sides. And negative 1 would make this unit equal to 0. We got to do it for our y as well in the bottom here. So y minus 3. So that's all of our r's. Let's do the y. So y minus 3 equals 0. Add 3 to both sides, and you'll find that if y was equal to 3, that would make this equal to 0, and then the whole bottom equal to 0. Now we can do some simplifying. We've got an r minus 1 in the bottom and the top. We've got an r in the bottom and the top. We've got a y minus 3 in the bottom and the top. And then y plus 3, r plus 1, and negative 1 don't share anything. So in our top, we've got y plus 3. And feel free to redistribute this negative 1 back into here. And just to simplify it further, so negative r minus 1 in the bottom. You can leave it as the r. Another way of writing it that would be acceptable is y plus 3 over the negative of r plus 1. Both are good. And our non-permissible value list is r cannot equal 0, 1, or negative 1. So negative 1, 0, or 1. And y cannot equal 3. That's all for this lesson. Thanks for joining me. See you next time.